Hello everyone, welcome to the Digital Electronics lecture class. In the previous lecture, we discussed the binary to decimal conversion. In this lecture, we will discuss the decimal to binary conversion. In order to convert a decimal number to binary, we will follow the double dabble method. So let us understand the double dabble method for converting a decimal number to binary. We will understand this with the help of some examples. The first problem which we have taken is converts 69, which is in decimal, to binary using the double dabble method. For this, we will divide the given decimal number successively by 2 and we will read the remainders upwards to get the equivalent binary number. So in order to use the double dabble method, we will make two columns. One column will show the successive division and the second column will show the remainders. Now we will go on dividing the given decimal number by 2 and we will write the remainders side by side. Since the given decimal number is 69, so we have divided 69 by 2. We will get 2 34s are 68 and there is one remainder, so we will put the remainder in this column. Then again we will divide 34 by 2. We get 217 times 34. There is no remainder, so we will put a 0 here. Then again we divide 17 by 2. We get 2 8s are 16. There is one remainder, so we have put 1 here. We will divide 8 by 2. We get 2 4s are 8. So remainder is 0. Again we divide 4 by 2. We get 2 2s are 4. There is no remainder, so we have substituted a 0 here. Again 2 1s are 2. There is no remainder, so we will put a 0 here. Then again 2 0 times 0. There is one remainder, so we will put a 1 here. So we will go on dividing the given decimal number until we get a 0 in the last term. And we will put the remainders side by side. Now, while reading the answers, we will read the remainder from bottom to top. So, reading the remainders from bottom to top, we get the result as 69 in decimal will be equal to 1000101 in binary. That is 1000101. In binary. So we will read the remainders from bottom to top. Then we will get the answer as 1000101. So the answer is 69, which is in decimal, will be equal to 1000101 in binary. In this way, we can convert a given decimal number to binary. Now let us understand how we can convert a given decimal fraction into binary. Now the method for converting the decimal number which is in fraction to binary, we will have to follow the a different process. Suppose we are given a decimal number 0.75, which is in decimal to binary, using the same method, that is the double dabble method. Now for converting a given fraction, means decimal fraction to binary, we will have to multiply the given fraction by 2 and we will have to keep the integers in the product as it is, and then we will multiply the new fraction in the product by 2. We will continue this process and we will read the integers in the product from top to bottom. So we will follow this process to convert 0.75 to binary. So we have taken the given fraction, which is 0.75. Now we have multiplied this by 2. That is, multiply 0.75 by 2. Then we get 1.50. Now we will leave this 1 as it is and our next fraction will be 0.50. Then in the next step, we will multiply this 0.50 by 2. We get 1.00. So there is no fraction part here because we are getting 1.00. So we will stop here. And for getting the answer, we will read this from the integer part from top to bottom. So if we read the integers from top to bottom, we get the answer as 0.75 decimal will be equal to 0.11. We will read in this direction. So this is 1, this is 1. So the answer will be 0.11, which is in binary. So in this way, we can convert a given decimal fraction to binary. Now suppose we have to convert 105.15, which is in decimal to binary. Now we find that this decimal number has integer part as well as fraction part. So we will convert both the integer part and the fraction parts separately, and then we will write the final answer. So as you can see here, we have converted the integer part here and we are converting the fraction part here. So if we want to convert 105, then we will successively divide 105 by 2 and we will write the remainders in this column. And while reading the answers, we will read it from bottom to top. So if we go on dividing 105 successively by 2, we will get the remainders as shown here. Now reading the remainders from bottom to top, we find that 105 in decimal will be equal to 1101001 in binary. Now for converting the fraction part, we will multiply the given fraction by 2. So we have multiplied 0.15 by 2, we get 0.30. Then in the next step, we will multiply 0.30 by 2, we will get 0.60. Again, we have multiplied 0.60 by 2, we get 1.20. Now we will leave this one as it is, and our next fraction will be 0.20. So we have multiplied 0.20 by 2, we get 0.40. Then in the next step, 0.40 multiplied by 2 gives 0.80. Again 0.80 multiplied by 2 gives 1.60. Now we will stop here because we are not getting 00 here. So after few steps, after 3-4 steps, we will stop and we will read the integer part from top to bottom. So if we read the integers from top to bottom, we get the answer as 0.15 in decimal is equal to 0.001001 in binary. Now after finding the integer part and the fraction part, we will write both the answers together and then we will get the final answer as 105.15 will be equal to this 1101001.001001 in binary. So in this way, we can convert any given decimal number to binary. Now I think you will be able to solve any given decimal number to binary.